Here's a question that sounds simple, but is secretly deep. How does a computer know that the word king is related to queen, but not really related to banana? It can't feel meaning the way we do. So it does something clever instead. It turns meaning into numbers. Those numbers are called embeddings, and they quietly power a huge chunk of modern AI. Welcome back to AI in 5. Here's the core idea. An embedding takes a word, or a sentence, or even a whole document, and turns it into a long list of numbers. That's it. A list of numbers that captures the meaning. Two things that mean similar things get similar lists. Two things that mean very different things get very different lists. Meaning, written in the language of math. Picture it like this. You feed a word into a special model, and out comes that list of numbers. Now, here's the fun part. You can treat that list as coordinates, like a location. So every word becomes a point floating in a kind of map of meaning. It's not a flat map with two directions. It has hundreds of directions, but the idea is the same. Everything gets a spot. And on this map of meaning, similar things end up close together. Cat and dog land near each other because they're both pets that show up in similar sentences. Cat and kitten are practically neighbors. But cat and car, they sound almost the same, yet they sit far apart because they mean totally different things. The distance between points literally measures how related two ideas are. This leads to one of the coolest results in all of AI. Because meaning lives in space, you can do arithmetic on it. Take the point for king, subtract the direction for man, add the direction for woman, and where do you land? Right next to queen. The model captured the idea of royalty and the idea of gender as actual directions you can move along. Honestly, it still feels like magic. So why should you care? Because embeddings are the engine behind a ton of things you use every day. Search that understands what you meant, not just the exact words. Recommendations that say, people who like this also like that. Grouping similar articles or products automatically. And, importantly, they're the key to feeding fresh, private facts into a chatbot, which is a whole technique we'll build up to soon. Compare the old way and the new way. Classic keyword search just matches exact words, so a search for car would completely miss a page that only says automobile. Semantic search, powered by embeddings, matches the meaning, so it knows car, automobile, and vehicle are basically the same idea. That jump, from matching letters to matching meaning, is a genuinely big deal. Step back and notice what we unlocked. Once meaning is just numbers, computers can compare ideas at lightning speed across millions or billions of items, even across different languages. The machine still doesn't understand like a human, but it can now measure how close two meanings are, and that simple superpower turns out to be enough to do incredibly useful things. So embeddings are this quiet backbone humming under the surface of modern AI. Words and ideas become points on a vast map, and closeness on that map means closeness in meaning. You rarely see them directly, but they're working hard every time a system seems to just get what you meant. So that's embeddings, turning meaning into numbers you can measure and compare. It's one of those ideas that, once you see it, you spot it everywhere. Tomorrow, we'll switch gears and talk about fine-tuning, how you take a general AI and teach it to specialize in your tone, your domain, or your specific task. See you tomorrow on AI in 5.